So if you need to, you come off to the side and write b squared minus 4ac. Best to put it in parentheses. Remind me, I'm sorry, I know I probably ask all the time. Are you allowed to use a calculator in this class?
Yeah.
Okay, and do you have one with you today? Besides,
Yeah.
the phone is not I mean, like, I don't care if you use your phone, but I would recommend you use something different than that if you have something different.
I have Desmos.
Okay, good enough. Yeah, or an app on your phone like that. Okay, will you calculate this for us, please?
Sure. Uh, 9.
9, yes. Okay, so that is the part that will replace what's under the square root. So this becomes minus 5 plus or minus the square root of 9 over 2 times 1. Okay, so go ahead and look at that. Just make sure you're comfortable with what's there.
Yeah.
All right, so from here, you have to take the square root of 9. All right, so that's minus 5 plus or minus 3 over 2. And in parentheses, the numerator is really in parentheses. Good to write that. So it's two things here. And I never know whether to go vertical or sideways on this, but it's minus 5 plus 3 over 2, minus 5 minus 3 over 2. And could you simplify that for us, please?
Sure. Is it minus 1 and minus 4?
Yes. Okay. So let's try to summarize what we've done here, because it's going to be the same in all the problems. You start by setting it equal to 0. So we'll see that in some future problems here where it's not 0. And you do want to get everything on one side of the equation. You identify A, B, and C. I think it's good to write them out just for clarity. You write out the formula, and what you can do is come up to the side and work on this part under the square root. That's where most of the errors occur when you're working on problems like this. And then you get that number, put it back under the square root, simplify the square root, and then you split it apart. You kind of the positive and the negative here. Okay, now it's like what I think, like when I look at a problem like this, you know, when I kind of can take a step back. I mean, there's kind of like steps. There's like step 1, maybe step 2, step 3, we'll say, I don't know, step 4. Okay, and you know, there's a lot of research out there that shows you if there's more than like 2 steps, that's where the struggle is. Because any one of them you probably know really well. It's just that you have to sequence them, you know, together in order. So let's try another one here. And let's make it a little bit harder here. Minus x squared minus 7x minus 6 equals 0. So I want you to calculate b squared minus 4ac for us. So notice I'm skipping step 1 and just basically saying, I want this result here.
All right. I got -21.
So that's really close. There's probably some sort of a sign error. So -7 squared. Notice I'm putting in parentheses. -4 times -1 times -6. Now, if yours does not look like this, be very careful here. So -7 squared becomes positive, right? That's 49. And by the way, if you put this into the Desmos Scientific, it will give you the answer here without having to worry about signs, but you have to do it with the parentheses around the numbers. And then it really depends on how you look at this. You're doing it by hand. Are you looking at it as -4 times -1 times -6? 3 negatives make a negative like that. And so 25 there is your final answer on that part.
Okay, I think I know where I got it wrong.
Okay. Now, I'd like you to tell me the quadratic formula here. It's okay if you need to look it up, but I want you to at least take an attempt here at it.
For this or just the quadratic in general?
In general, sorry, I should have clarified. In general, please.
X equals minus or negative b plus or minus
Okay.
the square root of b squared minus 4 ac divided by 2a.
Good. And there's probably some great TikTok videos on how to sing and dance to this if you want. That's not really my thing, but I know that could be popular.
Those are repulsive.
But they get so many views. Why is that?
I don't know.
Yeah, I don't know either. All right, now you've done most of the heavy lifting here. You've really done most of the work. You know the formula, you know the b squared minus 4ac. So b is negative this time. B is -7, okay? Meaning you have to put that in parentheses for b. Like b is the -7. Yes, you're going to negate it. Be very, very careful with signs because that is the key place that mistakes are made. And then this time it's 2 times -1. Now we haven't seen this before, but this is totally reasonable, totally allowed here for the bottom to be negative. So this becomes 7 plus or minus 5 over -2. All right, 7, 2 negatives make positive, square root of 25 is 5. Could you work this out and give me the final answers for this, please?
Sure. Yeah, -6 and -1.
Let's see here. I'm just double checking. I didn't do the calculation. -12 over -2, and then the other one is, sorry, +12 over -2. That is -6, and then the other one is 2 over -2, which is -1. Is that what is that kind of what you get?
Yeah.
All right. I'd like to do another here. Like you to do it kind of start to finish on your own. So I'm not going to make it too difficult for you, but I want you to give this one a try, please. X squared plus 9x plus 8 equals 0. So great chance for you to ask questions. If you're not sure about anything, it works out nice. No, nothing odd about this one. So go ahead and work that out, and let me know if you have any issues.
All right. I got -1 and 8.
Are they both negative, or you're giving me -1 and then +8?
-1 and +8.
Okay, so there's a sign error issue there, really close here. So A is 1, B is 9, C is 8. So this is -9 plus or minus the square root of 9 squared minus 4 times 1 times 8. What did you get inside parentheses here? What is
I
it?
got for the whole square root, I got 49.
Okay, so the square root of 49, that's good. Good, very good. So it's -9 plus or minus the square root of 49 over 2, -9 plus or minus 7 over 2. So does this look like what you have on your paper?
Yeah.
All right, so the two possibilities are -9 plus 7 divided by 2, -9 minus 7 divided by 2.
Yeah. Oh, is
Where
this one of those dumb addition things where
perhaps, I mean, the first one is -2 over 2, and the second one is -16 over 2.
Oh, it's the. I see now.
Sometimes it's easier to think about positive and negatives as negative is like owing, positives are having. Like if you owe someone $9, then you owe them $7 more, you now owe them $16. If you owe them 9 and you have 7, you still owe them 2.
Yeah. I don't know how that slipped me up. Out of all the things, I couldn't do it.
It really goes back to the fact that there's 4 steps and maybe 5 or 6 depending on how you look at it, but there's multiple steps. Okay. It's like when you're baking, if you might miss one ingredient if you're just not paying attention, and then the pie doesn't come out. But but pretty close. I mean, nothing to be too distraught at there. Okay, let's do another problem here. Before we do that, though, let's do some reducing roots. And then we'll come back to the quadratics. All right, let's try something. Let's try just numerical problems. So like let's say I asked you to find the square root of 40. Do you remember how you might start a problem this?
It wouldn't. What's the word? There is no whole square root, so you gotta break it down.
Yes. And how do you break it down here? What does that?
The tree, the factor tree or something.
Yes. So I call it a factor tree. It could be a ladder if you do it a different way, but you start with 2. You always start with prime numbers of 2. Then you move to 3, then 5, then 7, then 11 if necessary. Does 40 go into 2? Or I'm sorry, does 2 go into 40? That's misspecified. Yeah, does 2 go into 40?
Yeah, got 20.
Okay. And then does 2 go into 20?
Yeah, 10 times.
Yep. And then you try it again until it doesn't work.
Yeah.
Now, you look for pairs. I kind of liken it to like socks. I like my socks to match. Not everyone's like that though, but for this, assume you like socks to match. Any pairs come out. And anything that's not a match stays in. So in this case, it's 2 square root 2 times 5 or 2 square root 10.
Okay. I kind of recall that.
Great.
Yeah.
We're going to do another one here, and we're also going to get into some variable problems, but this is let me know when you get all this down and we'll move to another.
Yeah, I got it.
Okay. All right, so let's take the square root of 180. What number should we start with?
2.
2. And that's 90. And we try 2 again, because hopefully it works. Like you try something until it doesn't work anymore. Does 2 work? Does 2 go into 45?
No.
No. So you go to 3. Does 3 go into 45?
Yeah, 15.
Okay. And then you try 3 again.
5.
All right. Do you see any pairs?
Yes. 2 2s and the 2 3s.
So notice you only bring a 1 out. The pair, kind of liken it to you have 2 socks, you fold them up, you have like I don't know, 1. You have 1 that came from 2. Same thing with the 3. What about that 5?
You put it in the square root.
Yes. So on the outside, it's 2 times 3. You always multiply whether it's inside or outside. Square root of 5.
Okay. 6 square root of 5.
All right. So now time for you to try a couple of problems here. Let me know when you're ready.
All good.
All right. So square root of 60.
I got 2 square root of 15.
All right. Very good. Let's have you try another one here. Have you try the square root of 72.
All right. Got 2 square root of 18.
Okay. Did you try 3 at any point?
Yeah.
Like when you get to 18 here, 2 still works, but eventually you get to 9.
Yeah. Which
What does that reduce to? What's the next number you try?
3.
Okay. So that should change your answer just a tiny bit here. How does that change your answer?
The two to go into the square root, the 2 3's would multiply, and then the leftover 2 would also, I would think. I don't know.
So if they're the pair, they come out,
Okay.
and if they're isolated, they stay in.
Okay, so it'd be it would be 6 square root of 2.
Yes. All right, so let's try another one here. Square root of 300.
All right. That'd be 10 square root of 3.
Yes, perfect. Okay. All right. So the reason we have this little diversion here is we often want to do a quadratic formula problem where you have to reduce the root. Like it doesn't work out nicely. And so you have to be on the lookout for those types of problems. So we'll do a couple now, and hopefully this becomes clear. Just looking to see if there's any ones here that all right, so here's one for us to look at. All right, here we go. 3x squared minus 6x minus 23. A is 3, B is minus 6, and C is minus 23. Okay. All right, so first thing here is we're going to determine B squared minus 4AC. So that's parentheses minus 6 squared minus 4 times 3 times minus 23. Okay, so grab calculator and let me know what you come up with for that.
All right. I got 312.
Yeah. So that equals 312. So we write our formula here, minus b plus or minus the square root b squared minus 4ac over 2a. At some point you will just start substituting in as you go, plus or minus square root of 312 all over 2 times 3. So this is new because the square root of 312 is not known. We actually have no idea what it is. And this is where you have to reduce this as far as you can. All right, so I'd like you to give that a try. Just come off to the side here. What is the value of the square root of 312?
All right. Is it 2 square root of 78?
Yes.
Okay.
Where do you feel like you went with that, where it was like what was kind of more difficult about that one than say some of the others I'd given you? If
Just
anything.
kind of the thing in the square root felt a little bit too large, but it's 300, so it's gonna be larger. 312.
Okay.
Yeah.
Yeah, I mean it's like if they don't work out nicely, then is it because it almost looks like 78 should reduce, but it just doesn't. Okay, so that's going to take the place of this right here. All right, so that's 6 plus or minus 2 square root 78 over 6, like that. Okay, now this is something we have not done yet, which is you have to divide both of these by 6. So it's 6 divided by 6 plus or minus 2 square root 78 divided by 6. Now notice the way I'm writing this, I'm not putting the whole thing over 6. It is the whole thing over 6, but you want to remember it's just that number that you can divide by the 6 there. So in this case, it would be 1 plus or minus 1/3 square root of 78.
All right.
Any questions on that before we do another one?
All good.
Okay. All right, so another one. This will probably be our last quadratic for at least for now. This one's got a little bit of work to do. Will you calculate the b squared minus 4ac for us, please, in this problem?
Sure.
I think I gave you a bad problem. Hang on just a second before you keep going on that one. Yeah, sorry, I gave you the wrong problem. Why would I do that? Okay, 3x squared plus 9x minus 15. Yes, this is much better. Sorry for the previous one did not have a solution.
Got 261.
Yeah, very good. So x equals minus 9 plus or minus the square root of 261 divided by 6. Okay. Is that all right?
Yeah.
All right. Now 261 at first glance, you're like, well, maybe that's prime. 2 does not work because it's not even, but you got to you can't just be like, oh, I'm done. Use your calculator. Tell me if this is divisible by 3.
Yeah, it's 87.
Okay, now is 87 divisible by 3?
Yeah, 29.
Yes, 29. 29 is prime. So what does the square root of 261 become?
3 square root of 29.
All over 6. And just like the last problem, you have to divide each of these by 6. All right, so what that means for you is you're going to have to, reduce these fractions as best you can. They're the top and bottoms in both of these, the 9 and the 6 are divisible by 3, 3 and 6 are divisible by 3. So this becomes minus 3 over 2 plus or minus 1/3 square root of 29, like that.
Okay.
All right, what do you think? Any questions on that before we move on to something else?
No.
All right, so let's do the short amount of time we have. Let's do some roots of exponents here. Let's say it's x to the 4th, y to the 12th, and z to the 30th. If I tell you the answer is x squared, y to the 6th, z to the 15th, can you tell me why this is the answer on the right?
And when you do the square root of exponents, you got to find kind of, it's different from normal numbers. You just got to basically cut it in half.
Yeah. Now, why?
Because
Yeah. The question is, why is it 1/2? And the answer is, or that, and that is what it is. Now, the reason is because there's really a 1 here, like this whole thing, x to the 4th, y to the 12th, z to the 30th. There's really a 1 in a parentheses and a 2 next to the root, and that makes the exponent 1/2. And like it's kind of it's now one of those things where it's like, okay, I can give you more, I can try to explain that better, or we can just accept it. You can, it's reasonable to ask, well, why don't you write it? Well, it's because if it's supposedly known if it's not written, but to, first time student, that's hard to believe. But now you can see why you cut them in half, because you're distributing that 1/2 to each of those like that.
okay.
Okay. Now, similarly, this is probably our last problem. Let's say it's the cube root of x to the 9th, y to the 18th, and z to the 30th. If this becomes x cubed, y to the 6th, z to the 10th, can you tell me why that is?
So it's the invisible one. It would be 1/3.
It'd be 1/3. That's right. And so each of the exponents are divided by 3. All right. Well, you get